All right, this lesson is on normal distribution. Standardized test results like these for college admissions show a normal distribution. So it shows you student successes on a test and then the probability. And it shows what we call a bell curve of normal distribution. Probability distributions can be used based on either discrete or continuous data. Discrete represents listing out numbers like 1, 2, 3, 4, where continuous could be numbers like your height. So if you're, or shoe size. So it's something usually with measurement. Usually data results from counting and continuous data from measurement. Okay, you may be familiar with what we call the normal curve, which is bell-shaped. So this is bell-shaped. A normal distribution is a function of the mean. So the mean is going to go in the middle. And then it has standard deviation of 1, 2, and 3 positive. So that's plus 1, plus 2, plus 3 standard deviation. And then in the negatives, it'll be minus 1, minus 2, and minus 3. So minus 1, minus 2, minus 3. And then there's some attributes that make up a normal distribution. The probability assigned to a real number interval is the area under the curve, which the total area here is going to be 1. Or what we can think of as a percent, 100%. So that's the area under the curve. The maximum value of a normal curve occurs at the mean. A normal curve is going to be symmetric about a vertical line through the mean, so that's that line of symmetry. And the normal curve has an asymptote, horizontal asymptote, at y equals 0. A normal distribution curve is coinciding with standard deviations. The figure to the right shows you the percent of data that's going to fall within the curve and its parameters. So if we say this is the mean, again in the middle, 50% of the data is going to fall above, and then 50% is going to fall below. Then we say within 1 standard deviation, so this is 1 standard deviation, so plus or minus 1 standard deviation is going to be 68%. If we go farther out, to now this green region, 95% fall within 2 standard deviation. So this is plus 2 or minus 2 standard deviation. And the last area is within 3 standard deviation, which is 99.8% of our data will fall within 3 standard deviations. All right, so that's that same curve. So if I look at just positive 1 standard deviation, this is plus 1 standard deviation, it's saying 34% of the data set will fall within that region. And then this represents 13.5%, and as you progress out, the smaller the numbers get because we have a normal distribution curve where most of our data wants to fall within that 3 standard deviation. Okay, so here's an example. The trunk diameter of a certain variety of pine trees. So let's say we go out and we measure the tree trunks of pine trees, and we take the measurements, we enter them into our graphing calculator, and it gives us our mean. So our mean, the average, trunk diameter was 150 centimeters. So that's going to go into the middle of our distribution curve. So that starts off, that's the mean. Then the other thing it gives us in our graphing calculator is the standard deviation. So I just nicknamed that SD for short, just because. And so what we do is we create a set of values on this number line. So 150 is in the center. And then if we go +1 standard deviation, so +1, we would add 30 to our mean. If we go to +2 standard deviation, we add another 30 centimeters. And then 3 standard deviations, we add another 30. Then we want to go the other direction. So subtract 30, subtract another 30, and subtract another 30. So that's how you set up your normal bell curve. You sketch the normal curve, you put the mean in the middle, and then you do the distance of your 3 to the right standard deviations and then 3 to the left standard deviations. And now we're going to go ahead and answer some questions. What percent of tree trunks, that if we were to measure them, that would fall between 150 and 180? So I'm just going to erase this here so we can go back. Okay, so where are we talking? So 150 is right here to 180. So if I color that in, that area is within 1 standard deviation from the mean. So if we look back in our chart, I've already highlighted it here for us. That was that 34%. So our answer would be, what percent of our tree trunks will fall within 150 to 180 centimeters? Okay, B, what percent of tree trunks will fall between 90 and 210? So here's 90 to 210. So the area we're talking about is that region. Here's our middle. So we have 1 standard deviation, 2 standard deviation, 3, and 4. So 4 parts. If we go up to our chart, I erase this. What we do is we just add up those percentages. So we add up 34% and 34% and 13.5 and 13.5. And the percent that falls within essentially 2 standard deviations, because this is a +2 and this is a -2 standard deviation, is 95%. C, what percent falls less than 120 centimeters? So let's erase that. So less than 120. So here's 120. And we want the area less than, so all of that. So if we go up to our chart here, it's going to erase this, erase that. All right, that data point fell. In this region right here, so this was that -1 standard deviation, 2 standard deviations, and then 3 standard deviations. You just add up those three percentages. So 13.5 plus 2.35 plus 0.15 is about 16%. All right, example 2. The heights of adult women on a particular country is normally distributed with a mean, an average of 64 inches. So that's going to go in the middle. And then it says the standard deviation is 3 inches. So we add 3 inches as we progress on our horizontal axes. So then we go 70 and then 73. When we go to the left, we're going to subtract 3, so 61, 58, and then 55. All right. What percent of women fall within 61 inches? So here's 61 to 70. So I'm just going to put my vertical lines here. So here's 34%, another 34%, and then 13.5%. So we add up those. So 34 plus 34 plus 13.5 give us 81.5%. Okay, part B, what percent are taller than 67 inches? So here's +1 standard deviation. And so we're going to add this area, and this area. So we'd add 13.5 plus 2.35, and this area right here. So again, where I'm looking at is these 3 percentages. And then 0.15, and we get about 16%. All right, example 3. The following curve shows the scores for an SAT, which is designed to be normally distributed with a mean of 500, so an average score of 500, and a standard deviation of 100. So here's the 500. And then we see our horizontal axes. So every standard deviation plus or minus is 100. So it's asking us what percent of scores are between 400 and 600. So here's 400 and 600. Their area under the curve is within +1 or -1 standard deviation. So 34% plus another 34% is 68%. B, what is the probability that you'll score above a 600? So here's that +1 standard deviation. So you're going to add those 3 percentages together. So this percent here is 13.5, 2.35, and then greater than 3 would be 0.15. So we add up those numbers. And we get about 5%. Sorry, 16%. Oh my gosh. All right. C, what is the probability that you will score something less than 300 or greater than 700?
Okay, I found this on the web for what is the problem that will score something less than 300 or greater than 700. Check.
That's a first. All right. So here is +1 standard deviation, +2 standard deviation, and then +3. So we have to add up 2.35% and then 0.15%. And then same thing on this side. This is minus 2 standard deviation, minus 3 standard deviation, so it's 2.35 and 0.15. So we add up those numbers and we get 5%. And I'm just going to use that same image to go greater than 300. So greater than 300 is all of this. So one thing you can do is you can take the complement. So if I look at that bell curve, here's 300, and we want the more than. So one thing you could do is you can take the complement, that smaller area, and that smaller area is 2.35 and 0.15, and you just subtract those out from 100. So you can take 100% and then just subtract the two pink numbers. And you'll get 97.5%.